All right, so I've got some trig functions here, and I just want to go through and quickly identify the amplitude and the period for each one of these. So the amplitude, this is just going to be this outside number right here. It's like our vertical stretch or compression number. So in this case, that's a 2. All right. The period is how long it takes for the function to start repeating itself. And because this one it's got a 3 on the inside, it's going to repeat itself more often. All right, the period is going to be shortened from the original 2 pi. Usually it takes 2 pi for sine to start repeating itself, but this one's going 3 times as fast. So the period is actually going to be 2 pi divided by 3. All right, the way that you find the period is you just take 2 pi and divide it by that b term, by the inside number. Okay, let me show you a picture of this one. 2 sine of 3x. Okay, my amplitude's a 2, so that just controls the height of my function, I guess, or the distance from the tip top to the midline. And then this 3x is just going to make it repeat itself more often. Like if I didn't have that 3 there, it would take 2 pi units before it starts repeating itself, or before it starts completing a cycle. But now it makes a full cycle at 2 pi over 3. That's how long it takes for it to repeat itself. All right, in 2 pi units, you actually get 3 repetitions or 3 full cycles of the function. Okay. So that is our 2 sine 3x. Let's look at, can we get back to it? Yeah. Now let's look at negative 3 cosine x. Our amplitude for this one is a 3. It's actually the absolute value of this number on the outside. The period in this case is going to be the normal 2 pi units, okay? Because we're not adjusting the inside number, so it's just gonna, the speed of the function, it's not going to be sped up like it was with this 3 here. All right, it's like a 2 pi divided by 1. Now that negative on the outside, what that's going to do is actually going to flip our function across the x-axis. So the normal cosine wave starts here and starts falling, but because everything's been flipped over, all right, it's now starting at negative 3. So 3 is our amplitude, and then you see right here, the distance between these peaks right here, that's how you tell when the function repeats itself. So it takes it 2 pi units to start repeating. And then the last one here, we're going to look at a slow function, sine of 1/3 x. The amplitude is 1. All right, that's my outside number there. My period here, to find the period, I would do 2 pi divided by 1/3. Okay, this 1/3 is going to slow my function down, and so it's going to take longer for it to complete a period. 2 pi divided by 1/3 is, it's like 2 pi times 3 over 1. So that's 6 pi. That's how long it's going to take for this one to complete a full cycle. Okay, this one's going to look kind of wonky. If I scroll over here, there we go. It doesn't complete a full sine wave until it gets to 6 pi, because that 1/3, it's like a nerf on the function. It's slowing the function down. All right, let me look at one other thing here. This time I want to give you the graph, and we're going to identify the amplitude and the period from the graph. Okay, so the amplitude, it's this distance from the midline. It's the distance from the midline up to the peak. In this case, it is 1/2. All right, you see ones up here, so it's at the halfway mark. That's our amplitude. And then our period, we want to look at how long it takes for it to complete a full cycle. So what you can do, this looks like a cosine wave. So it's the distance from that peak to that peak. So that's going to be pi over 2 units. That's going to be my period here.